Bismillahirrahmanirrahim. Students, today we'll prove the condition partial square z by partial x partial y equals partial square z by partial y partial x for the function z equals xy plus y raised to power x. To start the proof, I will tell you here we need two important formulas to prove the equation. First one is chain rule, d by dx x raised to power n equals nx n minus 1, and the second one is d by dx ax equals a raised to power x and log of a. Let's start from the left hand side. Let's prove first the left hand side. We'll first differentiate the equation z with respect to y, then it becomes the derivative x raised to power y, which becomes x raised to power y log of x. Here we use the second formula, and for the derivation of y raised to power x we use the first formula. Now again we differentiate with respect to x. First we differentiate x raised to power y, it becomes y x raised to power y minus 1 and log of x as it is plus here we use product rule, so now it's the first term as it is and the derivation of second term is 1 by x plus. Now for this function, for this value we again use product rule, and the derivation of x would be 1 and y raised to power x minus 1 would be as it is. Now x would be as it is and the derivation of y raised to power x minus 1 would be this by using the formula number 2. Now for right hand side, we first differentiate the function z with respect to x. For the first term we use the first formula, this one, and for the y raised to power x we use this formula. Now again differentiation with respect to y, it becomes here we use the product rule. The derivation of y would be 1 and the x raised to power y minus 1 would be as it is plus here the derivative of here the y would be as it is and the derivative of x raised to power y minus 1 would be x raised to power y minus 1 log of y. Here we use the second formula plus to solve this now to solve this value, here we also use the product rule. The derivation of y raised to power x would be y raised to power x minus 1 and log of y would be as it is plus the first term would be as it is and the derivative of the second term would be 1 by y. So here we see, let's compare the values of the equation 2, let's say the equation 2 and the equation 3. We have the same values. The first term x raised to power y minus 1, here is we have the x raised to power y minus 1, and the second term y x raised to power y minus 1 log of y. Here in the equation 2 we have its last term plus x raised to power y x into y x minus 1 log y. We also have this in equation 2, and y raised to power x into 1 by y, it becomes y raised to power x minus 1, and in equation 2 we also have this term. So left hand side equal right hand side, and here we prove the required equation.